Good morning. Today we are going to discuss about another important title, that is a seed drying. So seed drying is very important post-harvest operations with reference to seeds, because that moisture content of the seeds have a greater role, both positive and negative role in the case of seed quality maintenance during storage. Say example, the moisture content of the seeds is in between 40 to 60% mean, that will induces metabolic activities that is related to the occurrence of the germinations, and moisture content of in between 18 to 20% normally induces heating. So the occurrence of the heating normally causes viability loss for the seed material, and the moisture content of 12 to 14% that normally favor for occurrence of the fungal population. That also a negative thing. The moisture content 8 to 9% is considered to be a safe for storage of the seed material, but in some other cases, with that level of moisture content also, that insect population will attack and causes problem to the seed material. So under that case, we have to treat the seed with some insecticides. So by that way we can prolong the shelf life of the seed material during storage. So from this, what I wanted to convey to you is that elimination of that moisture is very important. Then only we can preserve the viability of the material after harvest. So in that way, that seed drying is very important. Seed drying is a process of elimination of the moisture from the seed, is called drying. So that the elimination of the moisture from the seeds, that mainly depends on two parameters, that is latent humidity and temperature of the environment surrounding the seeds. So that latent humidity and temperature is very important parameters. Say example, when the latent humidity of the atmosphere is less when compared to that seeds, at the time whatever that moisture available in the seeds, that get eliminated. Suppose that the latent humidity is higher than that seeds, at the time that surrounding will start to donate moisture content to the seeds, the seed will absorb the moisture content. So that is not a good thing as far as that preservation of the seed viability is concerned. Similarly, with reference to that seed drying, so many strategies are available. So either heating or mixing with some chemicals, sun drying, like that, so many strategies are available. Whatever may be the strategy adapted for elimination of the moisture content or seed drying, and that should not induce any oxidation or decomposition or volatilization process in the biochemical constituents of the seeds. Suppose that induces oxidation means most of the seed that have more amount of the carbohydrate. So if at all anything oxidation occur in the carbohydrate, that will be broken into simple compound that causes serious problem to the seed health. Similarly, that oxidation, that lipid oil molecules available in the seeds also highly amenable for the oxidation process. So that also causes quality issue for the seeds. So whatever may be the strategy adapted for the purpose of seed drying, that should not induce oxidation or decomposition or volatilization process. So that is that things we have to take into consideration. And the another thing, through actually the drying, it's a moisture elimination process. So because of that, there is a loss in dry weight that is recorded in the case of a seed material. And the another important thing is that a high moisture containing seeds should not be exposed to high temperature all of a sudden. So if you expose the high moisture containing seeds to the high temperature all of a sudden, all the moisture content will be eliminated. So that leads to structural collapse and chemical decompositions. So to avoid that one, high moisture containing seed must be exposed to that shade condition. Then after reaching a sufficient level of moisture reduction, then we can go for that high temperature aided drying. So these are all the basic things we have to follow at the time of our seed drying. So regarding that seed drying, so this is not a one stroke process. Stage by stage we have to do this particular process. In between that stages also we have to give some break also. So then only that structural integrity and biochemical constants of the seeds, everything will be maintained, the viability also maintained. So in the drying process, actually two steps. The first steps, so we have to adapt the strategy to expose the seeds to that surrounding have a lower latent humidity. So at the time, whatever that moisture available in the surface of the seeds, that will be eliminated. So because of that elimination, there will be a moisture imbalance within the seed systems. So moisture imbalance between the outer surface of the seeds and inner core of the seeds. The inner core of the seeds have a higher moisture content, and the outer surface will be lesser moisture content. Whenever this kind of moisture imbalance is recorded, at the time we have to stop the drying process and keep the seeds and allow it for some times. So this particular period is normally known as a tampering period. So during that period, whatever that moisture available in the inner core started to migrate towards the surface. So by that way, that seed will try to establish moisture equilibrium within the seeds, that is the inner core and surface. So once that moisture balance is ensured between the outer surface and inner core, then we can expose the seed to the drying process. So at the time again that moisture will be eliminated. Then you have to give a break. At the time again that seed will try to ensure that moisture balance. So by the way, stage by stage we have to dry. So that is very very important. So then only we can preserve the viability of the seed material. So with reference to that different moisture content of the seeds, normally the seed that consists of water in three forms, that is a pre-water, bound water and absorbed water. Normally that seed having moisture content more than 14%, that will have a free water. Free water means physically available, not held by any forces. So for removal of these one, no need to apply any heat energy. So mere by the way of exposing the seeds to that surrounding have a lower latent humidity, we can eliminate that one. So that kind of moisture normally comes under these particular phase 3 things. So these availability of these free water totally unsafe for the seed material. So with that level of moisture, we should not go for that storage. So we have to eliminate that one. Elimination also possible. No need to apply any heat energy. Then another two forms of water are bound water and absorbed water. Absorbed water means get absorbed on the seed surfaces, held by very weak forces. Whereas bound water is a part and part of a chemical substances, maybe a part of a carbohydrate, part of a protein, part of some minerals like that. So for storage purpose, through drying process, we try to eliminate that total free water molecule and almost all the absorbed water molecule also. We should not disturb the bound water. If you try to eliminate that bound water, definitely that will induces all the biochemical process like decomposition, oxidation, volatilization, that ultimately leads to loss of the viability. So through drying process, we have to concentrate elimination of the free water and absorbed water. So in the phase 3, that normally that indicate the presence of that free water. Phase 2, that reflect that absorbed water. Phase 1, that is related to that bound water. So that phase 2, that is normally in between 6 to for 12% or 13%. So we have to eliminate the moisture content to the level of 8%. So if you go beyond that, so we must adopt some strategy and safely we have to remove. So if you try to extract more and more of that water, automatically there will be a chance for occurrence of the decomposition, all those processes. So because of that, 8% reduction is possible with the help of available instruments. Beyond that, we must pay more care towards that seeds. So that is very very important. So that in the case of pulses, we are recommending that 8 to 10%. For cereals, particularly paddy, we are recommending that 13%, and oil seed and all 8%. That is a moisture content. So this particular graph that give you that the correlation between the moisture content and latent humidity. The latent humidity increases, that moisture content level also increases. The latent humidity decreases, automatically that seed moisture content also decreases. So with that idea, we are going to discuss some of the machines used for seed drying operations. So this is a temperature normally we are following for drying of the seed with a different level of moisture content. The seed with a higher moisture content means that should not expose to high temperature. So if you expose to high temperature, all the three forms of water will try to escape, because here we are going to apply somewhat of the heat energy. So because of that, all the three forms of water will try to escape. There will be a competition among the three molecules. So but available area is only that seed core. So if all the three forms of water try to compete to escape, so there will be a structural breakage. So to avoid that one, suppose the seed have a more moisture content, that should be exposed to low temperature. Here that a seed with 18 to 30% moisture content, that should be exposed to 90°F. Suppose that the moisture content is 10 to 18%, so that should be exposed to 100°F. If it is less than or equal to 10%, that should be exposed to 110°F. So these are things we have to keep it in our mind, because now that artificial seed dryers are available. In that case, we have to regulate the temperature under for proper drying. So if at all that machines are employed, we are going to employ for the purpose of that seed drying means. So these are all the parameters that going to play a major role with reference to that rate of drying. So that is the initial moisture content of the seeds, size of the bin and its capacity, and depth of spread of the seeds, and rate of airflow, and atmospheric air temperature and latent humidity, and static pressure and drying temperatures. So these are all the important parameters that going to play a major role with reference to that rate of drying. So now two types of methods are available for seed drying process. One is a natural process, another one is an artificial process. In the case of natural process, we are mainly rely upon that sunlight. In the case of artificial drying, we have two different type of instruments. One is a batch process, another one is a continuous process. Again, in the case of continuous process, that is a continuous mixing type and a continuous non-mixing type. Like a variety of instruments are available. In that particular session, we are going to discuss some of the methods with reference to the natural and artificial. So first we can discuss about that natural drying, that is a sun drying. So sun drying is commonly followed in tropical, subtropical and warm temperate climate conditions. So this is not advisable under temperate climatic conditions. And also this method also we can follow only that sunny days, not advisable during the monsoon times. So here that for drying of the seeds, initially the seed will have moisture content of more, so that seed should not expose to direct sunlight. That should be put it under shade condition for about overnight period of time. So that condition also, that the surrounding atmosphere latent humidity should be lower than the seeds. Then only the seed will start to liberate that moisture content available in the seeds. So by that way we have to ensure. Then after substantial reduction of the moisture content, we have to keep the seeds and allow it for sometimes to allow the seed to establish moisture balance. So once that moisture balance is arrived, then you can expose the seed to that sunlight in the morning in between 8 a.m. to 12 noons. So at the time, frequent turning must be given. So all the seed surface should be exposed to sunlight. So whatever that moisture available in the surface, that will be eliminated. So there will be a moisture imbalance. So at the time we have to keep the seed material and keep the material until 3 p.m. So during that period of times, the inner core moisture will migrate towards outer surfaces. There will be a moisture balance. Then you can expose the seeds to sunlight after 3 p.m. At any cost, the seed should not be dried in between 12 to 3 p.m. because at the time UV rays activity will be more. That causes serious problem to the seed viability. So this is a process normally we are adopting for drying of the seeds with the help of the sun. So the main requirement with reference to sun drying is concerned, so frequent stirring must be given, mainly to promote the uniform drying, because all the surface of the seeds should be exposed to sunlight, then only even removal of the moisture from the entire seed surface. Then arrangement must be, we have to make it ready. If at all any rain occur, we have to put up a cover, so that also very important. And overheating should be avoided, and because of that only we need to give that frequent stirring, and protection must be given to the seeds against birds, rodent and insects. So these are the requirements we have to ensure in the process of sun drying. Then artificial drying. So in the artificial drying, variety of instruments are available: batch type, continuous type. In the case of batch, in the continuous type, mixing type, non-mixing type, like instruments are available. First we can discuss about that batch type. So in the case of batch type, batch in bin dryers. Here the bin dryers will be available. There may be a round bin, and heated air is in the bin. We have to stagnate that seed material from the bottom, and that will have a perforated bottom will be there. Through that perforation, that heated air will be flown. So by that way, whatever that heated air is flow into the bin, that will remove the moisture content. So that and so many parameters play a major role with reference to drying of the seed with the patch in bin dryers. Those parameters are initial moisture content of the seeds, type of the seeds used for drying, and air temperature, latent humidity, and fan horsepower, all those things. So to obtain uniform airflow through the seeds, a fully perforated floor is required. The bottom should be fully perforated one, then only that uniform distribution of the heated air will be occur. And in this case also, moisture gradient will be developed, so that the bottom of the seeds are directly exposed to the heated air, so that will eliminate that will remove the moisture content at a faster rate, whereas in the top, that is not directly connected with the heated air. So at the end of the heating process, the bottom of the seeds will have a lesser moisture content, whereas the top will have a higher moisture content. So here also the moisture imbalance. To avoid that one, frequent mixing must be given, so that is very important. So for that purpose, better we can have some seed mixer within that bin itself. So that should go for mixing of that seed material for about 3 to 12 hours. So that is very important. But anyhow, here that drying is not that much uniform. Then another type of dryer, that is a pin layer dryer. So this here we are going to spread the seeds layer by layer. So here that a successive layer of moist seeds are added periodically to the drying bin after previous layer have been partially dried. First we are going to spread that one layer and going to flow that air, so that will eliminate the moisture content. So after substantial removal of the moisture content on the first layer, then second layer will be added, then heated air will be flown. So now that moisture will be lost, again like that we are going to add, so that frequent one more successive layer we are going to add. Because of that, the final seed depth in the layer drying bin is much greater than the previous dryer. So this is another type of dryer. So this is also a batch process, column batch dryer. So here the seed will be flow from this particular column, and the medial that the heated air will be available. The seed will move on either sides at the time. So this way that the seed will come. The heated air will come this way. So the flown heated air will remove the moisture content. So whatever that seed reaches that bottom, that will be dried. So here that column specification thickness also given. Here that column thickness, that seed column thickness is 0.25 to 0.45 mm, and heated airflow rate also 15 to 30 meter per minute per meter of screen area, and heat also 35 to 40 degrees Celsius. So that way that the seeds are dried, but here that drying is not that much uniform. And another main thing is that the seed will be exposed to 35 to 40 degrees Celsius. So before packing up the seeds after drying process, that should be exposed to that ambient air in order to cool down the seed material. So another very popular and very commonly used seed dryer is a Louisiana State University dryer. In short, it is called as LSU dryers. So this is a continuous and mixing types. So here that this particular thing is mainly used for drying of the paddy seeds. So vertical things will be there. So here and there some triangular shape things are there. The seed will fall from the top and fall to the bottom through the gravitational force. So due to availability of this kind of triangular shapes, and the path of the seed movement get diverted. So because of that diversion, the seed themselves get mixed up, and the seed also take a zigzag path, and the heated air also flow from the right angle to the seed movement. So that seed will pass that entire column and reaches the bottom. The bottom we can check the moisture content. If it is a desirable moisture content is reached, we can remove the seeds, or with the help of that vertical conveyor belt, again the seed will be transferred to the top. That will be again delivered from the top to top, and that will take this route and reaches the bottom. So like that this process will be continued until getting that desirable moisture content. So it's a continuous and mixing type dryer. It's very commonly used for drying of the paddy. Due to availability of this kind of triangle shaped things, so the seed path will be diverted. So that will take zigzag movements and mixing also there. So because of that, complete drying will be ensured. So this is with reference to LSU dryers. Then another one is a rotary dryer. So this also a batch process, but mixing type. Batch process, mixing type. So this is a rotary dryer. So this particular part will continuous rotations. On inner side, this kind of provisions are available. So this kind of things are available. So because of that mixing also there, the heated air will flow on these directions, perpendicular to this. So all the seeds will be exposed. All the surface of the seeds also get exposed, and because of that, here we can ensure that uniformity with reference to that drying. But the only drawback is with the help of these dryer we can treat a minimum quantity seed material only, but uniform drying is possible. So because of that minimum quantity we can deal with this. Mainly this material is recommended for drying of the vegetables and floriculture seed material. The another drawback of this particular thing is it's a fuel operated, and fixed cost everything is more, and the maintenance cost also more. But anyhow, for that low volume high value seed material, this is a very good seed dryer. So this have a rotary column, so this will rotate this way continuously. This will rotate, and floated air will come inside, and this also have this kind of provisions. So because of that, the mixing will be possible. So these are all the things with reference to that rotary dryer. So as far as the advantage of that artificial drying is concerned, it's a quick method. Timely we can go for harvesting of the seed material. Uniform drying also possible. So physiological maturity stage we can harvest the seed crops, because the previous stage, due to non-availability of that artificial dryers, the farmers they will wait until that seed reaches harvestable maturity, then only they will harvest. So if you harvest the crop at harvestable maturity stage, that the seed quality will be affected. So now that technological advancement, that seed artificial dryers also available. So because of that we can go for that early harvest, and because of that over ripening, shattering of seeds, all those things we can avoid. And so during sun drying there is a chance for bad damage road, and all those things we can prevent. And this process also temperature everything we are going to regulate. So because of that there won't be any problem of the overheating and decomposition, all those things there won't be any issue. and there won't be any problem of the chun check, because if at all that sunlight intensity is more, that will create some sort of chun check. So because of that, internal crack will occur, so that will create some mechanical damage, mechanical injury to the seeds. If it is mechanically injured, the seeds not able to produce any normal seedlings in the germination test. Automatically those seeds are considered as a non-viable. So all those problems we can avoid by the way of drying the seeds in the artificial dryers. So even though this have its merit, this also have its own drawback. The first one is that the cost of drying is more, and fuel also need, either it's electricity or any hydrocarbon things are needed, and there is a chance for fire hazard, and we need a technical persons. So technical supervision is very very important. Just like that, we cannot operate these instruments. Apart from that natural drying and artificial dryers, we have some chemical also for the purpose of drying. So chemical desiccants are available, so that desiccants like silica gel, calcium oxide, lithium chloride, anhydrous calcium chloride. So the central we have to mix along with the seed material at a particular ratio. So the mixed chemical will reduce the relative humidity of the surrounding atmosphere. So once that surrounding atmosphere relative humidity is less, the seed will start to lose its moisture content. So by that way, the moisture content of the seeds will be eliminated. So these processes also available, but again the problem is the cost of the material and quantum of material needed for drying. So that is very very important. This technology general useful for drying of the small quantity of the seed material. If it is a large quantity, that we have to go for mixing up all those material. After drying, we have to remove all the desiccants from the seeds, so it's a laborious process. So even though this is technologies are available, so all these technologies are useful only for that small quantity of the seed material. So with that, we are completing that seed drying. So if you have any doubt, any clarification, that you can post your queries in the given email. Thank you.